Hey guys, guess what? We're gonna get into graphing today, which is super exciting. We're really only gonna stick with the parent function and then doing transformations with that parent function. So that's what we're gonna do today. Cool. So transformations of rational functions. The parent function of rational functions is the following. Y equals, or f of x equals 1 over x. Cool. No, it's not a line. No, it's not a parabola. It's not a log. It's not an exponential. It is its own type of function. And so the biggest things to think about are, number one, x cannot equal 0. So you will never have this function crossing 0, okay? Unless you've transformed it, obviously. But anyways, let's actually look at what that graph is going to look like. We'll make a little table and plot some points. Okay, so let's make a table, figure out what this graph looks like. I'm going to pick some pretty specific numbers, and you'll kind of see why. But basically, I want negative numbers, negative whole numbers, and then negative fractions that are really close to 0. And then I also want positive numbers, positive whole numbers, integers, and also fractions that are close to 0. So I'm going to start with, let's go -3, -2, -1, and then because it can't equal 0, bad things happen. So I'm going to pick -1/2. And then a little closer to that is a little closer to 0 is -1/4. So let's do that. And then 0 we write as undefined. And then let's go the same but for positive. So 1/4, 1/2, and then 1, 2, and 3. And figure out what those things are. So I'll go through the first couple and then I'll just fill out the list. So when x is -3, y is -1 over -3, which is the same as -1/3. When x is -2, I have 1 over -2, which is the same as -1/2. 1 over -1, that's -1. Now 1 over -1/2. That equals -1 over 1/2. But that is the same thing. Dividing by 1/2 is the same as multiplying by 2 over 1, right? Multiplying by the reciprocal. So this actually ends up being -2. -1/4, same thing. Similar process. You're going to get that equals -4. If I plug in 1/4 for x, I get y equals 4. 1 over 1 is 1. 1 over 2 is 1/2. And then 1 over 3 is 1/3. Okay, so then let's plot a couple of those points. Okay, my first point is -3. So I'm going to go over to -3 and then down to -1/3, which is about there. And then I put a dot. Bam. Then I go to -2 and then -1/2, so that's about there. Aww. Then I plot a point at -1, -1, -1/2. So I'm going to zoom in a little bit so you can see it. -1/2. I'm going to go to -2. Okay, so then I'm going to put a dot there. -1/3, which is about here on my x-axis, goes down to -3, and so on. Okay, now you can kind of see the trend here, right? And the further I go negative, the closer I'm going to get to the x-axis, but I'm never going to actually hit it, even though those look like it's hitting it. Same thing with the y-axis. So it kind of looks something like this, but it never actually crosses or touches the x-axis or the y-axis. My graph was just kind of bad. Okay, so that's the negative side. On the positive side, I've got 1/4, 4. Okay, so I'm gonna go to positive 1/4 and then go all the way up to 4 and make a dot. And then I'm gonna do 1/3 and 3, 1/2, 2, 1, 1, 2, 1/2, 3, 1/3, 4, 1/4. And you can kind of see the trend there. Same thing. It's never going to cross the y-axis. It's going to get really close to it. Same thing with the x-axis. It's going to get really close to it, but never actually cross it, which means the x-axis and the y-axis are, in fact, asymptotes. Yay, asymptotes. And there's our parent function. Woo, woo. So we're going to label this as y equals 1/x. Okay, so that's our parent rational function. So then if you do a transformation of it, you could multiply it by a constant. So if we drop down a little bit on the notes, right? If you multiply by a constant, so I take y equals 1/x, and I multiply it by a constant a, right? That's like a over 1, which is the same thing as a over x. Okay, so that's a vertical transformation, a vertical stretch, or compression, I guess. And then you've got this x minus h and plus k. And so the question is, are those vertical or horizontal shifts? Now, if you think about your original function, 1/x, if I plug in an x minus h, right, where am I going to do that? Okay, well, wherever x is, right? So I'm going to take this x and replace it with x minus h. So that's 1/x minus h. And then you know that is a horizontal transformation because it's inside the parentheses, it's inside the function, it's changing x, which makes it horizontal, not vertical, right? And then that plus k comes from, if I were to add k there, then I have a 1/x minus h, and then I'm plus k. So that k is my vertical translation. Remember, same thing we've always done with transformations. If it's inside the parentheses of the function notation, right? If it's affecting x, it is a horizontal change. If it's outside, it's affecting y, and therefore it's a vertical change. Okay, horizontal, vertical. Okay, so what I just did is I just copied and pasted my original parent function so that then we can just take that and transform it to get our transformed functions for the next couple examples. So f of x is -1/x, right? The -1 is just a vertical flip, right? So if my previous function looked like this, and I'm reflecting it over the x-axis, my new function's going to look like that, and like that. Okay, next example. This 3 here is a vertical stretch by a factor of 3. And then that plus 2 is a translation up 2, right? Because it's outside the function, therefore it's vertical, and we're going up 2. So I can take a couple points and move them if I want to, depending on the requirement for the graph. But basically what I want to do, a vertical stretch, you're multiplying every y value by a factor of 3. Okay, so this point that was 1, 1 now becomes 1, 3. Okay, so let's make that point 1, 3. The point that was 2, 1/2 becomes 2, comma, and then 1/2 times 3, so 1.5. And then, so we can start to kind of see the shape of this, right? It's just gonna be something like that, okay? And then the same thing down on the left side, it's just going to do something like that. Okay, and then we need to shift it up 2, okay? So my final answer is gonna be my, I don't know, the red one. So then I take this point and I move it up 2, I hate it when this messes up. Okay. I sorry. Okay. At this point, I'm going to shift up 1, 2. And then this point, I'm going to shift up to 1, 2. This point up to here. Okay. And then my asymptote that used to be the x-axis is now at 2. Right? This is y, the line y equals 2. And then this one that used to be the x-axis, again, I mean, it's going to have the same asymptote. So your function is going to look something like this. And then, whew, that looks like fun. All right, good stuff. So the red one is my final function. So f of x equals 3 over x plus 2. Yay. Okay, last one. Can you tell I've had coffee today? Anyways, last example is 1 over x plus 2 minus 3. So that x plus 2 in the denominator, that would have been inside the function, right? That's affecting only x. So that's a horizontal change. Remember, horizontal is opposite of what you think it should be. So that's going to be, instead of right 2, it's going to be left 2 because it's opposite of what you think. Okay, so this is left 2. And then that minus 3, that's outside the function, right? So that's affecting y. So that means that's a vertical shift up, or sorry, not up, down 3. So I'm taking my original function again, which is y equals 1 over x, which I've graphed on the on my sheet here, and I'm just going to move it left 2 and down 3. And the easiest thing, I think, to move, if it's just shifts, before you do any like stretches or compressions or whatever, is just to look at where your asymptotes are going to be. So my horizontal asymptote, which was the x-axis, right? I now need to move that down 3. So my horizontal asymptote is going to be this, the line y equals negative 3. My vertical asymptote, which used to be the y-axis, has moved left 2. I don't know which way to do that for you guys. I think that would be left because it's right for me. Anyways, sorry. I think the video flips the direction. Anywho, you move it left 2. So it used to be at 0, and it's going to be now at x equals negative 2. Okay, so those are my 2 asymptotes. So I'm going to erase the other 2 just so that you can see clearly what we're actually doing here. And since there are no stretches or compressions, you're going to have a point there, and then you can just kind of approximately draw it, draw your function. So it's going to get really close to the asymptotes, but never cross them, and have the same shape as the original function. Okay? So that's what that would look like. And this is a secret. Don't share it with anybody who hasn't watched the video all the way through. So it's only for you to know. The do now for tomorrow is just is to open your book, your iPad or whatever, and then just start working on the tech lab from 5.4. So just don't tell anybody. If I hear you telling people, I'll duck points from you.